Hi, I'm Dr. Billy Wu, and in this video we'll be talking about what affects your battery lifetime and how to make them last longer. Now, I'm sure many of us have had that situation where just as you need your phone, the battery dies, with this getting more and more common as your device ages. So the question is, what can we do about this to take better care of them? Well, one of the first things we can do is reduce the amount of time we keep our devices fully charged, as this can accelerate degradation. Of course, if you keep your device at a low state of charge all the time, it affects how much energy you have, but usually the optimum trade-off between energy and lifetime is around 85% state of charge. To understand why this is, let's revisit how a lithium-ion battery works. Here, there's three main components: a graphite anode, which is the negative half of our battery, a transition metal oxide cathode, which is the positive half of the battery, and a liquid electrolyte, which allows lithium ions to move between the anode and cathode. When fully charged, all the lithium is in the graphite anode, but when we discharge the battery, we remove the lithium and make it into a lithium ion and an electron. The lithium ions can go through the electrolyte to the cathode, but the electron has to go around an external circuit where useful electrical work can be done. At the cathode, the lithium ions and electrons recombine to allow the lithium to go into the cathode. When charging the battery, the reverse reaction occurs, which is why we call this a rocking chair mechanism. Now, over time, if we keep the battery at a high state of charge, this can accelerate the growth of the solid electrolyte interface layer, which is a passivation layer which forms on the anode. This layer consumes lithium ions, which lowers the capacity, but also as the SEI gets thicker, it makes it harder for the lithium ions to move through it, increasing the resistance, which lowers the battery power. In many smartphones and electric cars, there are options which allow you to limit the maximum state of charge of your battery, which does prolong the lifetime, but reduces the available energy. The next thing you can do to extend battery lifetime is to not let the battery get too hot. Here, the key temperature is around 70 degrees, where above this temperature, the battery can enter into thermal runaway, where this SEI layer decomposes, leading to the anode and electrolyte reacting, which is exothermic. If this temperature keeps increasing, this can melt the polymer separator in the battery, causing a short circuit, as well as the decomposition of the cathode and electrolyte, which can lead to the battery fire. Temperatures below 70 degrees can still cause damage to the battery, with warmer conditions accelerating degradation. This happens because the growth of the SEI layer accelerates at warmer temperatures, leading to decreased capacity and power. So the key takeaway here is to avoid putting your batteries and battery-powered devices in hot locations. Next, you should reduce the speed of charging. This is because fast charging generally degrades your battery faster, especially at lower temperatures. Again, many smartphones and electric vehicles allow you to turn fast charging on or off depending on your needs. Here, if you can avoid using it, this will extend your battery lifetime. The reason for this is that during fast charging, the surface of the graphite becomes saturated, meaning that lithium ions can't go into the anode. Instead, if we force them in, they'll form a lithium dendrite, which leads to capacity fade. If this dendrite keeps growing between the anode and cathode, this can cause an internal short circuit, leading to failure and fire. Next, if you're developing your own battery packs, one of the things you need to avoid is overcharging your batteries. For most lithium-ion batteries, they have a maximum voltage of 4.2 volts, but if you're working with lithium-ion phosphate batteries, this will be lower at about 3.6 volts. The reason for this is that if you overcharge the batteries, this can cause the liquid electrolyte in the battery to decompose, which is often the reason why some batteries become inflated. If this happens, you should stop using the device and dispose of it safely. For single cells, avoiding overcharge is more straightforward. However, for batteries in series, this can be more complicated since some cells might have different performance and thus a battery management system or BMS is needed. Here, in this example, you can see 3 cells in series, where the first cell has reached 100% state of charge, but the other 2 cells are only at 95%. If you kept charging these cells to 100%, because the cells are connected in series, it would mean that you overcharged the first cell, causing a potential hazard. Here, a BMS would balance the cells, to make sure this doesn't happen. And finally, you should avoid over-discharging your batteries. Here, if the state of charge of the batteries drops too low, then initially all the lithium in the anode is removed, which can destabilize the SEI. However, the more detrimental effect is that continued overdischarge can dissolve the copper current collector in the anode. This in itself isn't too bad, however, if this battery is then recharged, these copper ions can then form copper dendrites and short-circuit the battery. Again, this overdischarge problem can be more of an issue in battery packs with cells in series, where the cells aren't fully balanced. So, to conclude, here are the key points for how to extend the lifetime of a lithium-ion battery. Firstly, you'll want to reduce the amount of time at high states of charge, where the optimum is around 85%. The reason for this is that at high states of charge, the solid electrolyte interface layer grows much faster, which leads to capacity and power fade. Next, don't allow the battery to get too hot, with temperatures above about 70 degrees leading to thermal runaway and fire, but warm temperatures below this also accelerate the growth of the SEI layer and capacity fade. Fast charging can cause the formation of lithium dendrites, which can short-circuit your battery and also cause capacity fade, so where possible use slow charging. If making your own battery packs, avoid overcharging batteries, as this can cause the liquid electrolyte to decompose. And also avoid over-discharge of the battery, where the copper current collector can dissolve, and on recharge can form copper dendrites which can short-circuit the battery. In both of the last two cases, having a good battery management system, or BMS, will help avoid this. So, hopefully this provides some useful tips on how you might extend the lifetime of your lithium-ion batteries, and also for providing some understanding on the fundamental reasons why this happens. Do check out my other videos if you're interested in learning more about lithium-ion batteries.